Okay, this next part's on conventional current and electron flow. So for a circuit, let's just draw this first. So right here we see open circuit, closed circuit, and short circuit, and I'll explain these conventional and electron flow things. So just some terms we should know. So open circuit. So if I have a circuit, so I'm going to draw a battery. So a cell is if you just were to draw like a little line, a big line, and we put the plus on the big side and a negative sign on the other side. For a battery, we can draw basically multiple cells. A battery consists of multiple cells. So from here, it's just going to draw a very simple circuit. I'm going to draw a resistor. And I'm going to draw a switch. So for an open circuit, that's when this circuit is not connected. Okay. A closed circuit would be very similar to what we just drew. There's my resistor, and the switch is closed. So when you turn on the lights, you're actually closing the circuit. When you're turning off the lights, you're opening a circuit. So I'm going to draw that plus minus. So it says Andre Marie Ampere originally defined current as traveling from positive to negative. So way back when, they didn't really know what was going on. They just knew something was flowing. I think they originally thought it was some type of fluid. So they just had to go with something. So they defined current as traveling from positive to negative. Later on, they discovered that current actually consists of these electrons. Electrons are negatively charged, so they would actually be traveling from negative to positive because it's going to be repelled from the negative side, and the electrons are going to be attracted to the positive side. So in reality, electrons are going from negative to positive. However, most engineering textbooks or scientists, they usually go with conventional current, just because I think this has been going on for so long. And that is what I use as well. So all future examples, it's going to be conventional current, but just be aware it kind of depends on your teacher. So if your teacher decides to teach using electron flow, again, the math is all going to be the same, just they're going to draw arrows from the negative to positive instead of positive to negative. So when we see this battery, we think of this as we're going to gain potential as we pass by this battery, as we pass through this resistor that uses up electric potential. So I'd actually put a positive negative like so around this resistor. So if you imagine that current's going to flow around in this clockwise direction, it's going to gain potential, then lose potential. Gain potential, lose potential. And for the last one, a short circuit. If I were to draw a battery, let's just draw the same circuit again. So right now, I just redrew that. Short circuit happens is if you were like connect a part of the circuit such that we can that we accidentally bypass our resistor or our load. So in this case, think of it as electrons. They like to travel the path of least resistance. So if they were given this option, all the current is now going to travel down this path. And as there is no resistance now that's being passed by, just the wire itself acts as the resistor, which has a very small resistance. We get what's called a short circuit. So if we think of V is equal to IR, if we actually solve for the current, V over R, as R gets really, really, really small, current's going to get really, really, really big. So when you short a circuit, we get this huge amount of current that's going to pass through the wires, and that is what causes like dangerous things from occurring. It's like if you stuck a fork in a power outlet, you're creating a short, so now just all that potential from one end of the socket. I like to think of a socket. It has that one small one, that big one, and that bottom part. So we call this the hot. You don't really need to know this. This is more just general information. And that's our ground. So this is the hot end. So what actually happens is the electrons will flow from that side, and it'll complete the circuit when they get around back to this end. This ground, probably knows that not every single appliance or not every single thing you plug in uses that one. That's more so for larger appliances. Sometimes things like an oven or stove, they'll accumulate charge as they're being used, and that'd be bad if there's no place for that charge to go. So they'll actually have another connection to ground, so a place to take the charge, that excess charge, and literally take it away from the object, and yeah, just remove the, literally send it to the ground.